Yo, mic check, 1 2, 1 2. MCMG coming to you live in the actual, but in the virtual realm. I made up a whole bunch of new rhymes last night. I'm trying to think about whether I drop them now or in a recording of something else that I'm doing tomorrow. Maybe I'll do it now. Who wants to hear my new rhyme? Okay. So this is wait, say for the real lecture. Oh, that's a fair call. This is like a little side thing where there's not that many people here. Considering that my the amount of rhymes that I've actually written have not been as many as the number of lectures that I've delivered. Because for some reason, I don't know why, it's like important, I'm getting paid for it and all that kind of stuff. I actually put more time into the actual content than I do into my budding freestyle rap career, which it's probably never going to happen, but it's always a lot of fun. I'm going to assume from this that my microphone is working. And the questions are already coming in. Can I demonstrate a nested function in this lecture? I can definitely do that. So I'm going to assume by that we're talking about a function calling another function. So I've done at least one demonstration of this before, but I think it's fiddly things like this are always kind of worth looking at again. Actually, just the way that I think about it when we're learning about something like programming that has so many different techniques and not a great deal of specific clarity of which should be used when. I think it's really, really good to see things in multiple contexts. Basically, anything that I think that you need to remember, I'm going to teach you more than once. So if there's anything that I ever teach you that is not in the lectures and the tutorials and the labs, chances are it's something that isn't necessary for you to know right now. It still might be useful. I mean, I don't intend to deliver anything in the course that I don't think is going to be useful to you in some way. Can you just... It's like they turned on their siren and then drove really, really slowly. I always think it's quite funny that, like, how much I get sirens outside my house here. Anyway, so a couple of things that we're going to do today. Today, as you can see from what I've got on screen, today there are no lecture slides. And we may not even go for the full 2 hours. This is kind of like me starting the section after the lecture, immediately at the start of the lecture. So it's going to be just any questions people have, anything people want me to delve further into. The one thing that I want to start the day off with, though, is the lecture example we were looking at that I left in a state that I wasn't 100% happy with, and I wanted to show some other ramifications of what was going on. I don't know where I just typed in CD COMP1511 to one of my other windows just a second ago. Okay, so going to assume that it was in lecture 10 that we were working on the rhymer. So we were working on a little program that was, in a very, very simplistic way, checking the potential for a word to rhyme with a line. If we run this to remember what it was doing, I think I left some test code in there last time to show one of the issues, but we didn't get time to actually fix it. Oh, it's telling me there was nothing to rhyme with, because one of the things that we were using for this was command line arguments. So, what did we use last time? Okay, last time we were halfway through the course. So we were, whatchamacallit, we were using Bon Jovi's Living on a Prayer. Let's try something else today. Let's just see. Let's see how many people listen to this kind of music. wonder if anyone. I'm sure people know this, but not everyone's gonna know this. I'll tell you about it in a second. Okay, so please type in a word to rhyme. We've got this here. This was our testing code, which was telling us that when I typed in the command line, there were 6 words on the command line. The name of the program was that, and the rest of the command line arguments were this: light it up like dynamite. So this is the phrase that I typed in, and so I put a little testing code to make sure that I was reading those command line arguments incorrectly, which I think I am. Okay, and so if I want to type in a word to rhyme with that, I think tonight is one of the words. And we say, okay, we were testing tonight against dynamite, TONIGHT, and then we were testing enter as well. And so one of the reasons why we were getting a weird score here when we were trying to rhyme these is that we were also checking the new line, because we were accidentally taking the new line here when we were taking things in, I guess, from fgets. Okay, so if people didn't know, the line is from the latest song by a group called BTS, who are I think they still are the biggest K-pop group in the world at the moment, and that's their most recent song. So I don't know if people know, I like to listen to a bit of K-pop. I think I actually mentioned, was it this time or last time? No, it was this time. I mentioned Blackpink earlier because they just released a new album, and I was getting excited for that. I think it happened at the same time as one of our lectures as well. Okay, so people are asking me about other things that are happening this week. There's a stream on Thursday. Sorry, I just realized I forgot to get a cup of water, but anyway, I'll get that in the break. The stream on Thursday is, it's not a COMP1511 stream, it's something I'm doing with CSE Soc, which is, it's called A Brief History of Video Games. I'm going to go through video games and computer games from the very first games that were created and all through the development of history up until the present day. And then we'll sit around and have a Q&A and stuff afterwards. I know a lot of people ask often about how one gets into game development and stuff like that. And I've got some friends that work in it and things. I was going to try to get them along, but we ran into a whole lot of NDAs and stuff like that because the companies they work for are very, very careful about their marketing, so they don't necessarily want people just talking to media. And I didn't realize I count as media, but I do to a certain extent. The professionalism lecture, so Hardcore Minecraft, is saying the professionalism lecture is going to be on Friday. So the things that are for 1511 I put in our regular time slots, but I use this channel for some other stuff as well. So every now and then I've done some casual live streams. I don't know if anyone here has now or has had Daniel Mansfield as a lecturer. So Daniel and I met hilariously just because students told us both that our cats should meet, because we were both having cats turning up in our lectures. And so we did I think we did 2 streams together. Actually, once or twice I just turned up to his stream, and then we actually did a joint stream together on this channel. So sometimes I use it for things other than just the course content. But for this week, the course content's just going to be in the lecture time slots that we usually have it. But if you want to come along and you're following the YouTube channel, feel free to come along on Thursday for the games talk. It's got nothing to do with 1511. Apart from the fact that computer games are often written in C-like languages. I mean, a lot of computer games are written in either the Unity engine or the Unreal engines. Those are the kind of off-the-shelf game engines that people can use. And they're using C# and C++. So they're both C derivative languages. Anyway, back to the example here. Let's open the code and have a look at how we got that output. because we want to kind of refresh ourselves on what's going on here. So the program is going to take the arguments, it's going to check if there are command line arguments, and then it's going to go through the command line arguments, and it's going to basically find the final command line argument. So this was code for working with a single letter, but we went past the single letter and started working with a word. So we were going to take an input string using fgets. So this is a library function that was going to be able to take in a string from input. And then we were going to check the word which came in on that input line against the final word in the command line arguments. We're only looking at the final word in the command line arguments. And we had two functions here. Actually, Lin Rongkong was asking about nested functions. There's actually an example of it here. So we have one function that checks whether the character appears in a word, and we have another function that goes through all the letters of a word and sees if any of those characters fit in the word. So you can see that this function, check character, is getting called multiple times inside this function, check word. This would be one of the simplest ways that I would ever think of to use a function within a function. So what we're doing is actually reasonably simple, in that we have a function that does something, and it does something with an individual piece. It's actually the input character, an individual piece of something. And then if you were going to put this into a collection, into an array, so an array of characters, we could have another function that says, I don't just work on a single character, I work on a word of characters, so a string, an array of characters, and I use that function multiple times. When you think about it, like, there's a bit of extra stuff for calculation here, but all this function's really doing is making a while loop and wrapping up the call of that function in the while loop. So when we look at this check word and we break it down into like what are the essential pieces of this function, the only the major essential piece of this function is that it's a loop that has the function call inside it somewhere, which means that function's then going to happen multiple times, and then some information that it gathers. So there's very, very little going on with this check word. A lot of the thinking is going in this check character, but check word is there to use check character multiple times. So this is something that that I think is often a really useful way to do nested functions, because sometimes we may want to check an individual character, and that's why this is separate from checking all the characters in a word, which is what this one is doing. So you get this kind of ability for one function to use a function multiple times, and so it just uses the other function multiple times, but the other function can still be used on its own. And that would be why we'd often split apart functions in terms of each of them being able to do small things. So each function that we write has the kind of philosophy behind it is nearly every function that we write has as little code as we can. And it's weird, right? Because we're trying to move code into functions. But when I say as little code as we can, I'm saying that each function does one thing. So each function has one little purpose. So it doesn't have, say for example, I had check word or character, and I had another input that says, if this input is 1, you check one letter. If it's anything more than 1, you check that number of letters. And then we'd have the functionality of both of these functions in one. It might feel at a certain point that that's more, that's easier to use, but it's actually kind of the other way around, where if we put too many different types of functionality all in the same function, it actually means that that function gets a little bloated, and it's harder for us to say, I only want to use part of that at a time. Which is why this, even though, like, you know, we are fully capable of writing code that does this and this all together in one function, I still split these things up because of how they may be used later. So Lin Rongkong, that's a little bit of an explanation of what's going on here. Having said that, we can probably do another example that uses another function as well. Okay, so we hit a point at the end of the lecture where we're here and we're thinking, that's kind of wrong. Especially the shorter a word is, the more issues that we're going to get with this enter key appearing like it's part of the word. And we don't really want it to be part of the word. And the reason we're getting that is the characters in that word tonight that I wrote there are T-O-N-I-G-H-T, enter. So it's actually looking a bit like this. Hang on, where would it be? Type in the word there. At this point, input line is equal to something new line. So I'm going to put some English in here. At this stage, input line is equal to this, which means we've got that new line and we think, oh, that's a bit weird. We don't really want that. Let me just go to my lecture slides. Lecture 10. Because I did have some slides on this that I can't remember how much I wrote about what we were seeing here. Okay, so we got up to this point where we were like checking things and we were seeing some information. Then I was like, okay, new lines are coming through as part of our FGAT, so maybe we want to get rid of that. So one thing that we can do if we want to is we can find the new line and we can replace it with a null terminator, which says, well, let's finish the word early. Instead of allowing this new line to be part of the word, we're going to say the word's actually going to be one character shorter, and we're going to replace the new line with the null terminator instead. Josh is asking, can we ask some questions generally related to the assignment? You can ask any questions about any techniques that I've taught you so far. And so, considering that I've taught you all the techniques necessary to complete the assignment, you can ask me about general things, and I will answer them. So you can't say, how do I do this row column thing for painting a line like this? But if you say, can we learn about looping diagonally through a two-dimensional two-dimensional array, yeah, then we can look at it, right? So yes, I'm definitely open to questions, Josh, but they will be under the same rules of discussion that we actually have for the assignment as well. So the discussions for the assignment should be, we can definitely teach each other how to do programming techniques and stuff like that, but when we're telling someone exactly how to apply it to the assignment, that's when we're kind of doing the work for someone else, and it takes away their chance to kind of learn how to do things. So yes, I'm totally okay if you ask questions that when you read a little deeper into it, you go, hey, that's really like kind of would help a lot for the assignment, and then I will decide how much I'm going to show you if you ask a question like that. So yes, I've got no problem with you asking it. Okay, so we're going to think about this. Like if we think there's a new line at the end of the string, how do we find out if there's a new line at the end of the string, and then how do we replace it with the null terminator? And this is actually not that hard because we've used, I think, did we use string length in here anywhere? We did. We used string length. So we have something that tells us where the word ends. So if we're looking at where the word ends, we know what the index of the final letter is going to be. So at that stage, input line is that. Let's find, actually, I don't need to say let's. So I can say, find the final letter, check if it's new line. If so, replace it with null terminator. And this is actually pretty easy. When I give it to you like this, when I said remove the new line from this string, it's like, oh, what exactly are we going to do to get there? And now I've said, okay, let's break this down to the steps that's going to get there. It's actually not too hard to do. So what I can do is I can say, an if statement. If the final character of input line, so input line, and strlen is going to give me the length of input line. So string length of input line will give me the index of the null terminator. So the index of the first character that's not on the line, or the length of the word itself. So if I want the final letter that's actually in the word, which at the moment would be this new line, I do -1 on that. So this will get me the final letter. And if that final letter is a new line, then I'm going to do something with it. There may be an instinct to think that the final letter will always be a new line, and if it's always a new line, we don't need to do this test to see if it's a new line to change it. We'll just change it to a null terminator. The issue with that is fgets does not always end in enter. So there's ways to do input to fgets that will make the final letter not be an enter key. If you type in exactly max length -1 characters, then it'll put in max length -1 characters and put a new line. Put a null terminator on the end. Also, if you end the input to fgets using something like Control-D instead of enter, it'll do different things. So we are still going to go. Let's look at the final letter. Check if it's a new line. If it's a new line, we're replacing it with a null terminator. So I'm saying if it was new line, then we take that letter and we set it to a null terminator. All right, now let's check whether that's working or not, and we'll see when we check this what it looks like. So, I need to compile it. And that's taking a lot longer than usual. No, it's all right. Okay, so we've compiled that, and it's got no syntax errors for now. Let's try the same line again. I've still got all of my debugging printout there, which is probably something I don't need anymore, but I'm probably also going to leave this in the code so that you can see everything that I've written in this example. Cool. So, tonight, and this does have the enter on it, but then at some point, this thing finds out that there was a new line and replaces it, so now we only have the letters there. So that's everything that we needed to do for the rhymer that we were doing. I'll probably upload this again so that people have got this code. I did have some interesting challenges that people could play around with this if you want to. Bonus marks. Someone actually earned bonus marks the other day. Someone actually emailed me and found a discrepancy in the reference solution for CS Paint. So there was one thing that we were doing that that the reference solution was not handling properly, and their code was. So I think that's one set of bonus marks for someone this term. Okay, so the rhyming is a bit simplistic. Like the working out how much something rhymes was just how many times the letters appeared in the other word, which is not actually anything to do with actual rhyming. So I thought, is there a way that people could, if they want to, check better rhyming? So instead of saying, do the letters appear in the word, can we loop from the tail end of the word back through the word and make sure all the letters match exactly? Which is a reason why I set up this function, check character, like this, to return the last index that it finds the input character at. So if it returns the last index that it finds the input character, then what it's doing is letting you potentially go from the back end of the word forwards and find the indexes of the characters that match. So maybe you could use this function to do more explicit rhyming, which is like if these words are spelt very similarly going from the tail end back, then we're going to get a higher rhyming score. So that's something you can play around with if you want. There's something else you can play around with, which is an assignment on painting on a 2D canvas of arrays. So I think if you want to work on that, you can totally work on that instead. Yeah. Also, there are standard library functions that could replace some of our code. If you have a look in ctype.h and string.h, you may find that a lot of the code that I wrote in that example could be replaced by other people's code, and it might even be more reliable code. So there's another sort of exercise for this that you can do with this program, which is go through with a bunch of standard library functions and see if you can kind of nearly slim down the code and have it just as functions that you don't need to explain because they're standard library functions. Up to you. You can have a look at it if you want. All right. I should go back to questions because we do have a couple of questions now. So Trent said, when we declare a 3D array, how do we make sense of the indexes? So for 2D, it's like rows and columns. Does it become rows, columns, depth, or depth, rows, columns? So this is a really interesting and difficult one, Trent, because the rows and columns thing that I'm teaching you is not set in stone. It's not a hard and fast fact or anything like that. So it's not something that everyone in the computing world would 100% agree that we should do it that way. I did it as a convention because it makes it much easier for you to print things out, because you can't print a terminal in columns. So you can't run down the columns in a terminal and go back up. The terminal always goes one line and then goes down to the next line. So that's why we're doing everything in rows first. So we're thinking about rows as the outer coordinate and then columns as the inner coordinate within each row. So depending on how you are planning on looping through the data, you could then do it in different ways. So for example, if I had CS Paint, and instead of it being CS Paint, I'm giving away another assignment one idea that I may use in the future. Because I kind of like, when I can, I create new assignments, but CS Paint, if you look in the history of 1511, has run before. Just be super careful. Like don't read any of the code from previous CS Paints because it literally won't work. We rehash the theme of the assignment, but the things we're actually asking you to do are different. So if someone was to submit the last time I ran CS Paint, which was last year, if someone was to submit that to the current CS Paint, I think you'd fail. I think there'd be very, very little marks in it, because as much as the theme of the assignment is the same, the actual questions of what we're doing are quite different. But what was I going to say? Yeah. So you can look at no. I was thinking about previously. Oh no, I was talking about making lots of assignments. Right. So what was I going to say? Yeah. So a potential future assignment is something where we have a dungeon, and the dungeon has floors. Each floor is a 2D grid, and then when you hit the stairs on one floor, you move to another level of the 2D grid. And so I would potentially think of actually, I'm going to open this as a C document. I'm going to make a directory called, actually, do I have a live stream directory? Did I have one? No. So last time I did a live stream with you, it was just the assignment introduction live stream. I didn't really make a directory for that one. Okay. Get it? 3D demo. So we're not going to go too deep into 3D arrays. Get it? Get it? Too deep into into 3D arrays. But I'll at least show you how I might lay it out. We'll just go with void for the moment. I don't know if I'm going to go as far as actually needing standard input output here. But okay, so a 3D array representing a dungeon of same sized floors, because we can't actually change the size of the floor, so we're going to say no, we intended this to all be the same size, even though if someone was to dig underneath a castle and create a dungeon, it wouldn't necessarily be like that. So we could do an integer array for this, and then we can think of a floor as being a 2D array with rows and columns. I'm gonna have to hash define those. Int num rows. Let's just keep it simple. Why did I just... It's week 6. I'm also on week 6, where my brain just did not write C for a moment there. Somewhere between my brain and my fingers, that I was thinking about something else. I was thinking that the hash define was an integer value, and I just wrote int. And let's say there's 5 levels. So a single floor might be an array using number of rows and number of columns. Let's say this is a single floor. And if we want to, we can say an empty floor to begin with. But if I want to put multiple floors in a dungeon, then I might do something along the lines of multiple single floors. And if you think about it as multiple single floors, then what I'm going to do is I'm going to make an array, and each element in the array is going to be a floor. So the final element that's getting stored in these are integers, but it's nearly that the dungeon is going to store multiple of these. So it's like we've got multiple individual floors, and however many of them we're going to have is the number of floors. So what we do is we say, the first thing we do is decide which floor we're on, and then the next thing we do is we use this pair to say which individual floor we're on. Next week, when I start adding new content, this is all just a kind of revision of previous content. When I start adding new content, I'll show you an even nicer way of doing this, where we can actually kind of encapsulate this, where we say, okay, single floor, and we could do something which is actually nearly like this. So if you get the idea of what I'm doing here, I could create something where a single floor is a two-dimensional array of integers, and I could actually have that as a type and have a dungeon which is an array of single floors. And then that way what I'd actually have is a three-dimensional grid, but it would be structured in such a way that it is specifically an array of two-dimensional grids. And that kind of makes it easier to understand. I mean, the dungeon's easy to understand because you can think of these things as being physically stacked on top of each other and having coordinates each of their own. So you go, okay, so I do depth first, and then I move in amongst that depth and find my individual piece. It's sort of, you know, like, it's, this is a way that makes it easier to think about it. When you're doing three-dimensional arrays, it's just a matter of trying to find a way that you're going to remember it. So rows and columns makes perfect sense for us in CS Paint, because we think about printing this thing out. And we think about printing this thing out, we print a row at a time. So that's why row is the more dominant, I guess, coordinate. It goes first because we'll finish everything on a row before changing to another row, whereas we can switch around between the columns more often than that. So Trent says, awesome, thank you. So hopefully that's helping. Yeah, I guess the main point of it is that we're never sure, right? We're never sure whether people are fully understanding this. But this example is something that kind of gives you a hint that maybe if you know how you're going to encapsulate bits and pieces, then you say, if this is a piece and I have multiple of these pieces and that makes up my 3D array, then that's kind of how you would do that. Yeah, but this thing later, I'll show you later, is this thing called structs, and we'll talk about that later. Okay, Josh is saying, if we have a function that needs a bunch of arguments, say 8, is that a stylistic fault? Is there a way we could reduce this, say by putting some into an array? So let's continue this example here, and let's have a function. I don't even know what the int is going to be from this. Okay. This is something we would get this. Okay, move player. So what I'm basically doing here, basically writing another assignment. So I'm just like, I think it would be cool for the students to have to move the player. So what we would need then is we would need to have player. We would need to have an integer for the player floor, an integer for the player row, an integer for the player column, an integer for direction, and a dungeon array, which is a 3D array. I'm going to copy this because I don't want to have to write it out again, which is of size num floors, num rows, num columns. So how many is that? 1, 2, 3, 4, 5 at the moment. And it could get bigger than this. So I'll just see if Josh is saying it and stuff. Okay, so as a stylistic fault, let's look at what might be an issue with style here. I think the biggest issue is we've gone over this line, but a secondary issue is that there's a whole lot of information in this, and so it's a bit fiddly. What I might do is just something like this to begin with. I can line that up like that if I want to, or I've shown you another technique for how to lay out brackets, right? So when we were doing layouts for curly brackets, we could say we can do the same thing for single brackets. And if we want to be really, really like specific to show exactly how many inputs are coming in, I could, hang on, I'm going to close the bracket underneath the same line that opened the bracket, so that way I can scan down, or like look at all this white space and wait for this. This is one way I could lay this out, so stylistically that wouldn't be a problem. Another thing that I could do, so let's say I'm not going to fill it all out, but let's say, for example, I had something else. So let's say I have this function. And so now I'm getting sneaky and getting a bit tricky with what I'm doing. I have a function that finds the player. So I don't know if this is the right thing to do, because we don't have any other code around this that says whether this is a good context or not. Oops. Not sure how that enter key came in there. So thanks, Max 10. I called you Max then because I mixed both your names together. For pointing that out. That's that would have broken things. Having said that, this whole piece of code doesn't actually work because I'm only doing bits and pieces. But let's think about this function here. I have a function that tells me where the player is. So now, if I want to, I may not need these. So what I can do is I can say int player floor player row. So player floor, player row, player column, and then I get say find player the address of the player floor, address of the player row, and then the address of the player column. So what I did then was I took out what needed to be input here and I said, maybe let's write another way to find this. So maybe there's another way that I can provide this information, or there's another way that I can look through my dungeon to find where my player is. And I've made a function that actually kind of has three outputs. It has a floor, row, and column as its outputs. They're not outputs, but you can think of FindPlayer as us writing something that finds out what these numbers are supposed to be and writes them into the memory locations where they're being asked for. So movePlayer says, I need to find the player, so I will set up these variables and then I will write into those variables using this other function that's going to find my player. And then the issues that I have with how big my function's getting might not be as bad because I can find another way around them. You're asking about assignment 1 and I'm doing pointer stuff, so it's not necessarily something that you want to do. But very often there are ways to think about what information needs to go into the function and what is the kind of minimal amount of information that needs to go into the function, and is there another way around it. So it's always hard because we're not going to talk about specific examples here, but something like this might be able to break your work up into parts so that you don't necessarily need all of it at once. And I do understand that one of the things I did there was use pointers. You don't have to use pointers in the assignment. There may be another way around it. Yeah. So I don't know if that helps or not, Josh, but maybe that's some food for thought as well. As you're saying, very interesting. I was thinking we should just pass floor, row, column as an array, like player location 3, but I suppose that hides information. I wouldn't necessarily say that's a bad thing. So the player location is always, in this dungeon thing, the player location's always going to be 3 numbers. Like there's no other information. The player's not magically going to go into a 4th dimension. Unless I want to put that into stage 5 or something. Oh, that's a real, oh, wow. I mean, I've just ruined it by talking about it on stream, but imagine that as an assignment where you've got to move someone through a 3-dimensional dungeon. And then what I do is I ask you to do a playback of the person. And the way that I ask you to do that is to move them through a 4th dimension. And the 4th dimension is time. So what you have is a 4th thing of location, which is time step. And so what you do is you loop through time step. And then... I saw that Jamie was just talking about time there. You had the same idea. You didn't have to delete those messages. You didn't have to delete those. Those were cool. Jamie was just talking about what if we move through time, and then you totally didn't have to you retracted the messages. You totally didn't have to. That was okay. You had that totally. So what we'd have is the 4th dimension, and you'd loop through time steps, and then you'd see if the 4th dimension matched up, and if the 4th dimension matched up, the person has to be in another location at that time, and then that way, if you have something that steps through time, the little person would follow the path that they'd walked through. Yeah. And we've just figured out that Jamie is a time traveler who has figured out what I was going to say before I said it, accidentally let slip that they're a time traveler and just gone, oh, message retracted. No, I never said anything like that. A game called Megakure. I don't know that game. I'll have to look it up. So it's a game that actually involves tracking where you were at different points in time. That'd be really cool. I'm going to do an aside here because we don't have any official lecture content, so I get to talk about random things. I promised I would talk about random things in these streams as well. So I have a very unscientific yet feasible proof. It's not proof at all. Theory. It's a theory of why humans never invent time travel. So think, for example, that 2020 being a very significant date in human history because it is the year of the coronavirus pandemic, and there's other great events that happen in 2020 that are studied in the future. If time travel is a possibility, then we as a time become a tourist destination. And if you look at any photos of any tourist destinations, so for example, a photo of Leonardo da Vinci's Mona Lisa, the painting that is in the Louvre in France. I remember when I went there and saw it years ago, I took a photo not of the painting because I couldn't get a photo of the painting. I just took a photo of the people looking at the painting because there were so many people and you just couldn't get in to look at the painting. Well, if you wanted to, you sort of have to push through people for like an hour to like slowly work your way to the front to actually get a look at it. And so if any particular point in time was a tourist destination, then what we have is an infinite future of people, worth of people, all wanting to visit a particular place at a particular time. And so that means that any particular significant moments in history would have what is nearly an infinite number of time travelers looking at it to see what it was like. And so the chances of that nearly infinite number of time travelers turning up somewhere and not giving themselves away in some way is basically impossible. So that's my theory of why humans never develop time travel. Because if at any point in our future we develop time travel and then we exist as a species for a significant amount of time after that, someone has come back here and given away the fact that it exists. Unless that theory is correct, Jamie is the time traveler and has given it away now. Except none of us believe it because they retracted the message, so there's no evidence. Unless I go back in time on the stream and see those messages before they're retracted, if we replay the live chat. Anyway, little aside, a little bit of fun there. Let's go back to coding. Okay, so as Josh was saying, we were just talking about storing the player location as a set of 3 integers. So we could actually have something like this in our main. So we've got dungeon this, and we can have another hash define. And we're going to go with 3 for now. So we can have int player location is dimensions. This is actually really long variable name and a long hash define. So I'm using up a lot of my width here, but I mean, I'd probably shorten it to like something like player lock or something like that. But yeah, we could definitely do something like that where it's like, okay, the player exists in 3 dimensions, and so long as we're careful with that and we make sure that these are always in the particular order, so it's always floors, then rows, then columns, we could do that. I think this is actually a fine example for me to use today because I would definitely not give a first assignment to students that is a 3-dimensional array. If it's fundamentally a 3-dimensional array, that's a really mean thing to throw at people first go. Especially when my baseline for what I want everyone to learn is to be able to loop through like a 1D array. So if you have to ignore 2 of the coordinates and loop through another, it's still quite difficult. So it's enough, I think, that we're in 2D at the moment. Maybe what I would do is I would do a 2-dimensional area that someone has to move someone around in, like the tourist, expand the tourist example. And then stage 4 or 5 would say, okay, now we have multiple levels. Can you go through and make this stuff happen? I don't know. Developing an assignment takes a lot longer than we have time for right now, but I mean, it's kind of nice, I guess. I'm showing you a bit of the process that goes into the background, because this is an idea. So this idea, I came up with this idea with, can't remember who I was working with, some of the subject admins, not even just for 1511, just talking with some of the subject admins, and we put together an idea like this. And then I think when we workshopped it a bit, it felt like it was too much work with this 3D dungeon and stuff like that. So I think it's okay. I may never end up using it as an assignment. Okay, let's go back now that we've proven that Jamie is from the future and is meddling with the time stream, and see what other questions we had. So that was Josh's question about the multiple arguments, and we were fiddling around with ideas for that. So Eric is saying, where the assignment has comments like add your code here, do we leave those comments in? I would take those comments out. What I want to present as your final assignment is something that someone can use, nearly not knowing that a student made this for assignment. So we can look at the final thing that you submit as a program that has been created, and is being passed around for other people to use within a company or within a particular structure that they're using it. So we don't want leftover bits and pieces. Instead, we just want, okay, this is presented as a release in a sense. So we've taken things like debugging out of it. We've taken the to-dos out of it. I mean, obviously, if you're hitting, say, stage 3, so you're doing pretty well in the assignment, you're pretty happy with how you're going, and you've completed stage 1, 2, and 3, and you're like, okay, good. There's my submission. I'm not necessarily expecting you to go through and clean up stages 4 and 5 from those comments, because you haven't done them, you know? So if you haven't even looked at that section of the code, I don't need you to go through and clean that up. But I think the bits that you have implemented, especially if you've already sort of replaced that add your code here with code, then you don't need a comment saying add your code here. Instead, you've probably got a comment explaining the code that you've written. Izzy says, if you make an array in a function, can you use it in another function or main? Okay. So let's look at something like, if I had another function that says void create dungeon, and it takes in an int for floors, an int for the number of rows, an int for the number of columns. Let's say that's not a void. I wonder if this is going to work. Let's create a function that gives back an integer pointer. So let's take this. I'm already thinking that as I write this code for this demo today that I don't want to give it to you, because it's just such a mishmash of half-created code that's just answers to questions that makes no sense. I mean, this kind of makes a little bit of sense, but not entirely, right? Because I'm not writing full code here. I'm just writing snippets to show you ideas. So create dungeon is going to create a new dungeon, which is an integer array, new dungeon, 3-dimensional integer array. Maybe we should have used something less than 3 dimensions as the demos. But I mean, like, you know, you want to see it sooner or later. Has the number of floors that we were given, the number of rows we were given, and the number of columns. For starters, this won't work. So the first issue we've got is that we can't create an array. It doesn't matter how many dimensions it has. We can't create an array using variables as its sizes. So let's cull that immediately and just say, we can't give you the size of the dungeon, but we just want you to create a dungeon and give it back to us. So what we can do here, at least, is we can use our hash defines. So number of floors, number of rows, and the number of columns. So now I have created my array, and I said I was going to give back an integer pointer. So if I want to, I could give back an integer pointer, which the word new dungeon as the name of an array will give us the address of the start of the array. So if I want to, I could say return new dungeon. Let me just see if there's other chat that's been happening. Luna's saying, maybe time is just defined by humans and maybe it doesn't exist. So maybe time is our way of looking at a space that we can't see and we're all moving through at the same speed. That's quite possible. Roman's asking, how do you move the tabs in VLab? As in these tabs? I'm not actually sure. Can you drag them? That doesn't necessarily do anything. I know that we can go into different workspaces. So there's 4 different desktops. But I haven't actually tried moving the tabs around there. Oh, Raman's saying that Stephen Hawking said the same thing as me. I must have heard that from Stephen Hawking and then just forgotten it and then made it up myself, and I'm like claiming credit for something that I read someone else say. Okay. So going back to where are we? Izzy's question. Back there. I just realized Izzy's question was like half an hour ago. But it's alright, I'm going to get through as many questions as I can. I'm going to do them in order. Okay, so if we have this situation, what happens to this? So it is an array, but it's also just a variable. I want to say just a variable because it still follows all the rules of variables. So what happens is here is the curly brackets that surrounds this variable, which means that once we hit this curly brackets and we go back to our main or something like that. So I'm going to say, let's just say an integer pointer that points at the next dungeon. Let's say it's a game with like multiple levels, and it's not just levels down, you go to a new dungeon. Next dungeon equals create dungeon. So I'm saying that I can make a new dungeon here and then give back access to that dungeon, and then I'll have a pointer that gives me access to that dungeon. The downside to this is this variable that I create disappears once I finish this. So the variable exists only inside this function and does not exist outside of this function, which means this variable, when this function finishes, it will be in the memory assigned to that function, and that function will wipe. Actually won't wipe it explicitly, but it will say all of the memory I used for that function is now gone, which means that we returned a pointer to wherever this 3D array was created. Only by the time we come back here and we've got that pointer set up there, the array that we created here no longer exists. So at the moment, and again, I love questions where people are leading into what's coming next, because it means I've set up the narrative of the course correctly. One of the next things I'm going to teach you is how to create something in a function that stays, that actually stays longer than the function itself, doesn't get cleaned up automatically by the curly brackets, and we can use later. So we will actually definitely be getting to the point where this idea of us creating something in a function will be possible. But for what I've taught you so far, this isn't possible. And this in particular will get destroyed once... It's not actually technically destroyed, but your access to it will go away once this function itself finishes. So hopefully that helps, Izzy? Oh, great. Izzy's just letting me know that they're still there. Awesome. Yeah, so hopefully that helps to know that like you can't create something in a function expecting it to exist longer than the function. Every variable like these that are created inside a function will only last inside the brackets of that function. Jamie was saying, did someone say D&D? Yeah. It's been ages. It's been years since I played any D&D. I played a Shadowrun campaign with some few friends before the pandemic started, so last year, but since then I haven't really. I think ever since we went into lockdown, I've gone on a massive computer gaming spree instead of any of the tabletop games that I usually do. Like, I'm very much more a tabletop gamer than a computer gamer, but actually that's just currently. But in the past, I've been more of a computer gamer. It was really easy to slip back into that when we couldn't go anywhere. Okay, going back through some questions. Lin Rongkong saying something like a stereo image. So when we were talking about 3D arrays, that actually made a lot of sense. So we could have a stereo image where it was like the floors could have been a two element array, one which is left eye and one which is right eye. So we could actually use CS Paint if we wanted to do a VR thing where each one is a screen inside a VR headset, and then if we had enough of our little numbers in there, we could do perspective and stuff in 3D. Okay, I don't know if I'm going back too far in comments now. Oh, Raman's just saying, I think some of your knowledge just got transferred to my brain because I finally just figured out a section of the assignment, so I just wanted to say thanks. You're welcome, Raman. And I think that's kind of useful and important, so hopefully that comes through, that like what I'm teaching you was just about stuff in general, but then the assignment's got a whole lot of important things like that. So let's just talk to Izzy, because I was looking at that question. If you make an array in the main, you can use it like a pointer in a function. Yes, because the main is still running. Yes, the main's memory is still there. But you can't create it in a function and use it later. Yeah, so it's all about these. So when we hit this closing bracket, our entire program finishes. But when we call this function, it opens a curly bracket and it eventually closes it. And these functions will happen inside the main. So the lifetime of this function is just this line here. So it doesn't exist before this line and it doesn't exist after this line, which means we can't access anything in that function in this line here. So if I say next dungeon, how many times have I spelled dungeon wrong this lecture? And so I start trying to access stuff like a particular coordinate in the dungeon. That won't work, because the only time that 3D array existed was the time that this function was running, which was just within this line and at no time before or afterwards, because it's closed inside its curly brackets there. Whereas this one that we create in our main, we can pass it to another function, and it exists all through the running of that function, because the running of that function kind of happens only in one line in the main that it uses it. And because this thing's curly brackets are bigger than the function itself, then we can know that it's going to exist when our function is running. Okay. So I just noticed people were talking about time travel. Eric's saying it depends on your type of time travel. If time travel puts you into a different dimension, then time travel might be possible. So our particular dimension that we're in now is one where time travel doesn't exist. But the second someone creates time travel, we will move into a different dimension, and everything in the past will have changed. I don't know if you're allowed to use temporal terms when you're talking about time travel. Anyway, let's not get too deep into it. Raman's saying, how do you move the tabs in VLab as one? Or you're talking about the windows in VLab. I'm not entirely sure what you're asking there, Raman. So I apologize. If you want to, you can rephrase it and see if I get it. Nasa is asking, I think, about the same thing. Why is create dungeon function a pointer? It was because what we were trying to do was think about the idea of, if we create something in a function, can we still get access to it in the main? And so if we were going to create it and we still wanted access to it, then we needed a pointer to it. Having said that, we didn't have to do this with a pointer. So I could have something else. I could have the same situation where it's create integer, for example. And so I can have int x equals 10, return x. And so now we're in a similar situation, right? Where we've made something in a function and we would like to give that thing back, and then we want to use that thing somewhere else. And so if we're going to do that, if I try to give back this x variable, the x variable is contained within these curly brackets. So when I give it back, it will cease to exist. So when I return from this function, all of the variables inside this function will no longer exist and no longer be accessible. And so the point at which I return is actually the point where this thing disappears. And so if I have something, for example, oops, typing. So if I had this create integer function that was going to return an integer that I created, and I said something along the lines of int number is equal to create integer. This is a poor example as I'm doing it, because this works. What we'll get is the number 10 will get set into this number. So at this point, number is actually equal to 10. because what we actually did here is x doesn't exist anymore, but the value 10 gets passed back. So number is equal to 10, but x doesn't exist as a variable anymore. The only thing that came back out from create integer, sorry, I'm gonna call this properly. I'm definitely not giving you this code file because it's full of random musings and typings from me. So this is in no way gonna run. I think this, if I gave you this code file, it would just confuse people. But I'm using it as kind of a whiteboard at the moment, this screen. So x doesn't exist, but the number 10 gets put into here. So I can't now just say x is now 20 because x doesn't exist. So the variable that I created in here gets destroyed and I can't use it again. However, if I want to take this value 10 out of this and return it here, I'm still going to get the number 10, but that doesn't actually mean that x is still there. Okay, let me just see if there's any other. Yeah, Eric was asking, I think, a similar thing there. Can you get around this without pointers? Since without them, our functions can only return one thing. Oh, no, that was, Eric was asking then about I think that you were asking his previous questions here about, like, removing the number of things. We can't necessarily. I think that if there's a minimum amount of information that needs to go into a function, it is the minimum amount of information. We can just make sure that we separate things carefully. We can also, without using pointers, I'm trying to think of situations. I think there's going to be ways where layering functions on top of each other means that you don't necessarily need as many inputs and functions at the same time, but I can't think of a perfect example of this right now. So I'm not 100% on that. Okay, it's 10 past 12 now. Let me take a break, because I've just done the first hour without having a cup of water next to me. And I usually like to at least take a drink in between a section of talking. So I'm going to take a quick break. Probably won't be a full 5-minute break. Let's just take like a 3-minute break, and I'm going to get myself a cup of water, and then we'll continue. I'll be right back. with water so that my throat doesn't die. It's a weird thing, you know, where like a significant portion of your job is just talking. It's not just talking. There's a lot of thinking going on behind the talking, but still, I always never really thought about it. And I thought, people who are, you know, actors and singers and stuff like that go through a whole lot of training and exercises and stuff to make sure that their voices never have problems. They can deliver exactly how they want. And I actually used to watch that kind of stuff because I worked in theatre for a while, but I was working in theatre behind the scenes, not on the stage. Except when I was a musician, I was on stage then, but it's different. But I wasn't using my voice for either of those. And I never thought that I would end up in a situation where I might actually need all those voice exercises I saw people doing. Okay, so Eric has a question that I hadn't quite gotten through. Oh, Izzy was also saying create dungeon won't work. Yeah, create dungeon won't work. It's going to make an array that only lasts as long as the function itself, and then it's gone. There is something that we'll be able to do for that. Soon I'm going to show you how you can actually make a variable that doesn't automatically follow the curly braces rules. But we'll get to that later. I'm not going to go into detail on that kind of thing right now. So Eric's wondering about how to break down a function that has too many inputs. And I'm trying to think of a good example for this, but off the top of my head, I can't. So oftentimes when people are trying to do a lot of things in one function, they need a lot of inputs. Or even they're just trying to do something basic in a function, but the function still needs a whole bunch of information to make it work. I think it's okay to, if we go back to without using pointers. So if, say, this FindPlayer didn't exist, and we did actually need all of these things that I had before. Just gonna this is even going to be more than that potentially, because I don't know how the player's location is currently stored. You might even need something like destination floor, destination row, and destination column. So you might, because I think the original question, was it your question, Eric, originally? Who was it? Oh, it was Josh's question originally. I don't know if you're still there. Josh, that here we have the 3 dimensions of the player's original location, where they're going to move, which might not be just an integer. This movement here might also be a 3-dimensional thing, because it might be how far did they move between floors. So are they at a staircase where they're going to move up and down floors? It might be how far did they move in the rows direction and how far did they move in the columns direction, which means this movement might be 3 integers. And so things just get continually complicated like that. The way that we're working right now, I haven't really given you enough yet to be able to shrink this down. But for example, the idea that we had here of the num dimensions and the arrays, that's a possibility. So the player location could be an array. And so we could say, this one's a 3D array, this one's a 3D array, and maybe this one's a 3D array. And then what that does for us is actually removes pointers from this, even though it's not really, because the arrays and pointers are very similar in a sense. But it means we could think about these things, and we wouldn't even need a destination, because if we had an array of the player's location, we have access to change it. So we've created an array of the player's location and the dungeon. We pass both of them into a function, and then we don't need to say anything about the destination the player ends up in, because we're just going to go back and change the array that we were given. Because any array we pass into a function gives access to the variable that's in the main, or that's in whatever higher level function that's calling the other function. So in this example, I could potentially cut this down a lot by doing the following. I know, Eric, that I'm really kind of fudging this, because you said, can you do it without pointers? And I'm technically doing it without pointers because I'm using arrays, but that's really kind of still using pointers because I'm still passing around memory addresses. Oh wait, it's not a three-dimensional array. It's an array with 3 elements in it. So this would actually potentially work. So you've got the player's location, and it has 3 dimensions. But because you've passed it in as an array, the new location that you end up in afterwards just changes whatever array got passed into this function. So this is a way that we could definitely do that. So you could think about that, but I don't know whether that actually helps for your assignment or not. I can't remember if there was any time where we definitely thought we were going to use something like this in the assignment. I'm not going to go into like full-on details about that kind of stuff either. Oh yeah, Josh is still there. So hopefully for Josh and Eric, this is starting to maybe give you some ideas about things, but I think also if you lay it out correctly, you can have a function with lots of inputs. If you were to lay it out like this and put 10 inputs there, if it was necessary, it's fine. I think that your tutors would probably look at that, and looking at the code there with the multiple inputs and the context of all the code around it, they might give you an idea about, they might know why you don't need it. It's hard for me to know why you don't, because I think that you might not need it, but it's hard for me to know why without looking at your code. But when someone does look at your code, they can help you with that. I can suggest actually, if you take that, the 8 input function to a help session this week, for example, you could say, okay, so I've got this. I can make it stylistically nice. So I can do my brackets layout so that it's really clear how many variables are going into this function and what they're all called and things. But I still think that maybe this is too complex. Is there a way maybe I can break this down? And it won't really be the function itself that changes. It'll be the context of how you're using things in your main that might change. So it might actually be a big change, but then that you might learn something about how what we do is this thing called refactoring, where the code, the functionality of the code doesn't change, but just the layout and the way that things access each other change. And sometimes that can make things more readable. So Nasa's saying, I think it's supposed to be FindPlayer num dimensions. Oh yeah, yep, you got me. That was, I think I was just, I was just at that point. Yeah, you saw the, when I was putting multiple brackets there. Oh, sorry. I get what you mean. Comma, not semicolon. Yeah, that would, a semicolon there would break the declaration of this function entirely. I went on instinct, as you can see there. I went on instinct because I ended a line, and I've just got such an instinct for semicolon on the line. Okay, so that's helping Eric. That's good. Okay, are there any other questions I missed? Because I did scroll past a bunch of the chat a second ago, so that I was talking to people who are currently talking about things. So Nasa's question, which was the why is the create dungeon function a pointer? I think we've already looked at that one. Jamie's asking, will we use pointers to pointers in this course? No, we will not. But there are places where you can kind of see them, and where they could be useful. So for example, if I have this array and I consider this array to be a memory address of the beginning of the data in the array, then it's an address. If I have a pointer to an array, a pointer to array is nearly a pointer to a pointer. So you could kind of say that there's a certain level that we're sort of using pointers to pointers, but at no point will I... Okay, let's look at this. This is an interesting thing. Okay, so I have a pointer. And it points at an integer. So what do I call it? Player health. And somewhere else I've got an integer called health, and that's like, oh, let's not start them at 0, let's be nice to them. Okay, player health is equal to address of health. So I've got a pointer to something like that. And so this variable player health is a pointer. So I could technically, it's technically possible to make a pointer to player health, which means it's a pointer to a pointer. So it's a pointer aiming at another pointer. So this pointer is a variable. This pointer is also a variable, and it aims at this one, and this one aims at that one. I'm just going to spell this out. I would never use a variable name this long, but I'm going to spell it out. Because this is usually a point at which people go, I don't really know what's going on here, which is 100% fair enough. So this is a situation. If this is weird to you, if this looks strange and you're like, I don't want to do this, then that's okay for now. Learn normal pointers first, and then we'll get to these. So this is a really like an example that doesn't have much else going on. So I haven't given you a reason why we might want to do this. But this is like, if I want to know where the pointer is that leads us to the integer, which is the player's health, we can do it like this. So this is the variable type for a pointer, and then the pointer always aims at another variable type, and the variable type here is a pointer. So we've got a pointer to a pointer, and the pointer to a pointer stores the address of the pointer. So it doesn't store anything to do with this initial variable. It says the variable that I'm looking at is this other pointer, and then you use the double star later to access. So if you want to access that variable, you'd use 2 stars on this variable or 1 star on this variable, and you get access to this one. It's got its uses, definitely. I'm not going to say it's not useful. I'm just going to say that while we're learning the basics, stuff like this might not be that useful to us, because what it's going to do is just twist our brains into knots, and we want to avoid doing that a lot of the time so that we don't necessarily burn ourselves out with like, what is going on here. But there's definitely uses for it. For example, if we're going to use this dungeon situation, we could consider that the dungeon contains an array of pointers that aims at an array of pointers that aims at an array of numbers, in a sense. It's not exactly like that, but sort of. When you go into multiple dimensions, you can get multiple dimensions of pointers as well, and they get used like that. We're going to be doing things that are more sort of fundamental to learning about programming. Jamie's retracting messages again because you've gone into the future and then seen what I was going to talk about, and you've accidentally answered me on a different timeline by the looks of it. I actually didn't catch this one this time, so I didn't know what you were talking about. So, what was I going to say? Yeah, so yeah, this is possible. It's definitely possible, and it was always possible because any variable type can be pointed at by a pointer, and a pointer is a variable type, right? So definitely possible. We're not going to be using this. We're going to be doing other things with pointers, which is hard. If you're looking for hard stuff with pointers, we're definitely going to be doing it. But the stuff that we're going to be doing, which is interesting with pointers, is going to be far more useful. questions to the organization of data and ideas about more flexible data structures than arrays. Because as you've seen, arrays are very inflexible. An array contains all the same data. An array is always a fixed size. Changing the order of elements in an array is really fiddly. We can't remove elements from an array. We can replace values, but we can never remove anything, like as in it can't change size. I can't say take the last element off this array. So it used to be a length 10 array, now it's a length 9 array, and the final elements disappeared. So we're going to be going into things that will be able to do that. But not yet. Okay. How are we going with questions? Because I'm happy to take any more questions that people have from anyone who's here. But otherwise, it looks like the questions are sort of drying up at this point. In which case, I don't think there's anything more that I necessarily need to or want to talk about. Because I'm definitely not going to present any new information today. I've already dropped several hints about what I'm going to be doing next week, actually. I guess if you want to look up things, next week we're going to have a look at this thing called structs. And we're going to look at memory allocation as well. And we'll be going kind of actually answering a lot of the questions that you had today, and there are ways to use this concept of the multiple dimensions in one variable. Structs are going to help us with that. This question here about creating something in a function, memory allocation that we're going to work on will actually fix that as well. So I think it's really cool actually that everyone's looking at the way that we're coding right now and saying, how do we make this better? And I've actually got this set up for you that I'm going to teach you in a week's time how we're going to make this better. I don't know necessarily if any of the stuff I'm teaching you now would have made a difference to how you do assignment 1, but maybe a little. But they are setting up the groundwork for what we're going to do for assignment 2, which isn't coming out until the end of week 7. So assignment 1 due end of week 6, and then you've got a week off, and then the second assignment comes after that. So Jamie was asking something, is COMP1511 data structures and algorithms good to take after this? If you want that kind of flow, so the 2521, I don't know these courses off by heart because I haven't taken them. At least I did take data structures and algorithms when I was an undergrad student, but it's just a long time ago, right? But as far as I know, and it's actually potentially better to talk to people like CSCSOC, because you'll get people who are doing it now or did it last term and stuff like that. They will tell you what kind of stuff is in it, but from what I know, I think that it's, I always get these mixed up because the codes are so similar. It's either 2511 or 2521. 2511 I think is the Java object-oriented stuff course, but 2521 might be data structures and algorithms, which takes a lot of stuff from the second half of 1511 and extends it. So in the second half of 1511 I'm going to show you data structures that are not chunks of memory that are all stuck together. They're like disconnected pieces of memory, and the only way they all know where each other is pointers that go between them. So you've got just like these chunks of memory that you've allocated, and then the memory all tells you where the next piece of memory is via pointers. They're definitely going to expand on that into more complicated memory structures. And it's super, super interesting because the idea of pieces of data linked to each other is kind of the basis for a lot of the really, really kind of I'd say, I'm trying to think of a good adjective for this, other than, like, I was going to say full-on theory of computation, theory of mathematics level computing stuff. So I think there's lots of people like what I like to think about is like programmers or computing professionals are on this scale in a sense, and the scale is distance from computer. So some people are really close to the computer, and a lot of what we've been doing in C is getting really close to the computer. So you're giving it individual instructions and getting it to do things. If you do 1521, which is another subject that can follow on from this, you go downwards. So you get even closer to the computer and you start programming in. So for example, this here we do as one line in C. Set up a variable x, give it this value. If you do 1521, you can see the 8 instructions it actually goes into to actually make this thing work. And you can go onto that level and actually do it. COMP1511, as far as I know, goes upwards a little and says, these theoretical data structures that we're using, what's more complicated versions of these that we can do? Can we build structures that aren't just, like an array is just like a row of numbers. And then we can make grids of numbers and things, but can we make these expansive formations of data that link to each other in interesting ways? You could think of it as a stepping stone towards something like the human brain, which is just a whole series of things linked to each other, but all the links have different lengths, and all the links are different amount of strength based on the number of synapses that connect to each other. It's much, much more complex than the kind of data structures that we've been using, and capable of creating thought in a way that our current data structures that we've got in 1511 are not capable of, but we can build towards that capability. So we're working towards, the idea of, like, people talk about neural networks a lot nowadays because they're one of the most successful AI algorithms that exist at the moment. So they're reasonably popular because of that. The idea of pointers is kind of the fundamental thing that leads to that. So pointers is one piece of memory gets access to another piece of memory. In neural networks, one piece of memory passes information to the other piece of memory, and that pointer link is nearly the thing that does that. It's not exactly, but it's how we get access to the other thing, and we send information along that link. And then we have multiple links together, we build this kind of simulation of the human brain. So that's a long way. I mean, if any of you are in computing degrees, then this is a path that you can take. So you can go through and learn these things and slowly build up your capability with these data structures until you can get to the point where it's like, all right, now we're genuinely making a simulation of how we think synapses work in a human brain. Yeah. No worries, Jamie. I find that end of computing quite fascinating. So when I'm talking about that scale of distance to the computer, in both directions it forks in different ways. So you get closer to the computer, you might go into stuff like operating systems, or you might go into stuff like embedded systems, which is slightly different. Not always that different, but slightly different. But when you go away from the computer, you can go off in different directions. So one of the things that I did in my computing career is I went away from the computer in 2 different directions. So in one direction, I went into theoretical computing. So I went into this kind of stuff like where you spend 3 weeks at a whiteboard and then 1 day at your computer, and that's a good month of work. Like I literally would code for at most a week out of every month, and the rest of it was like intense discussions with other academics about why something should or shouldn't happen. This is what happens when you're building AI, I think. It's like you really need to think about how it's going to think, and that's very difficult. So I was off on that theoretical computing side, but then I also did a whole bunch of work on human-computer interaction, which is another way to not be worried too much about the nitty-gritty of how the computer runs, but we're thinking about how computers affect people and how computers relate to people, and how this relationship back and forth, and how important it is. So the way that I used to actually teach part of the human-computer interaction course here. I was like one of the tutors. This was back when I was not a lecturer yet. The way I used to describe it, which I find really interesting, is think about bandwidth. So think about, like, if I'm on NBN in Australia, which is, it's sometimes fast, but it's not the best. It's not by no means the best internet in the world, but we're going to expect a kind of a baseline at least of somewhere around 1 megabit of data per second. So 1 megabit of data, let's do our calculations, knowing that there's 8 bits in a byte, is roughly 1 megabit's actually not that much, is it? So 1,000 divided by 8, 125 kilobytes per second, which is not that much. We expect much more data than that. 125 kilobytes. Let's just, for example, have a look at this code we're looking here. 1.2 kilobytes. So I expect over a basic network connection like that, I can send roughly 100 of these per second. So 100 of these files per second. And then I say to a human, can you type in 100 of these files per second into your computer? And no, you can't, and no one is capable of doing that. I would be impressed to see anyone who could type in this much code accurately in 20 seconds, 30 seconds. So the bandwidth of the connection between the human and the computer is incredibly low. It's immensely low. It's so low compared to any other kind of data transfer we can do with computers. So it becomes the most major bottleneck for computing. So one of the things that I think, if we can talk about this, we're not even talking about whether computers are serving humans correctly or whether we're enjoying our time using computers, which is just on purely the idea of data transfer. The worst thing we have between humans and computers is the amount of data that can go back and forth at any time. And like typing in a keyboard is also incredibly low bandwidth. So anything that we can do that makes it easier for humans and computers to transfer information between us is going to be a major, major step in terms of how much better computers are for humanity. And so that's why that became really interesting to me, because a lot of people were putting a whole lot of work to get, say, 5-10% increase in speed in networking, for example. And this is hilarious because, like, when I was doing this was around the time people were doing a whole lot of moving financial companies around so that they were a few meters closer to their local stock exchange, so that the speed of light transfer of networking information would let them get a few trades in before other companies. And they were spending millions of dollars to get a 5% efficiency gain in their networking hardware. So like all those super amazing high-speed networking cards that they sell to gamers nowadays, those are real, and they came out of that arms race from the finance industry. So it's just really, really funny, those kinds of things that happen. So those little gains, when you consider that just a nicer interface for people to type things in, or a nicer control structure for people to move around their code and things like that, is worth a much, much higher percentage gain of information transfer than nearly anything we can do with our networking hardware. And so that idea stuck in my head and I couldn't get it out, and I was like, we should be putting so much work into the interface between humans and machines. Because the keyboard is a simulation of the typewriter. I don't know when the typewriter was invented, but the typewriter was invented before electricity, and we're still using it. Like, how are we still on something that old and we're thinking this is acceptable? And we've made so many leaps and bounds in other forms of the technology, but like the things that we're holding in our hands when we're using a computer, that's the limit. That's what we've got. And I find it weird that we still haven't created anything better. But I don't know, a lot of much greater minds than my own have been looking at this for years and haven't necessarily been able to push any new ideas. So I don't know what the limitation is, but I just see that it exists. And it's like one of those things where as an engineer you see a problem in the world and you really want to fix it, but whether you have the time to actually do it is another story. Anyway, that's you know how I give those lectures on the theory of a computer and stuff like that? This is something that I could have put in there, but it's not really it's not super relevant. It doesn't help you with C or anything like that. But I think in terms of like thinking about programming and stuff like that, discussions like this are very useful because we think about what it means to be contributing something to the computing industry. So those two forks that I talked about that are like more distanced from the machine itself, you can actually approach the possibility that completely necessary and very, very important parts of the computing industry don't do programming. Like there's no code. Like, that person that's designing that algorithm for 3 weeks could just hand it off to someone else to program. And the person who's designing how we actually... So someone went and created gedit, and they said, okay, which colors are going to work for people and stuff? Are the line numbers going to make sense? This little thing with the brackets maybe saves how much time overall amongst all the people that use this? Could be heaps. I don't know, and also how to type, or even something simple like select all these lines and then move them around. How much is that saving people, right? So yeah, there's all this really interesting stuff going on, and just thinking about that might not have anything to do with programming. It might still be like vital to the future of how we work with computers. So I always find a lot of that stuff really interesting to think about, because we're going to be focused a lot in your degrees on giving you a certain amount of technical aptitude, so that you understand these things and can potentially code things in the future. But when we think about everything that needs to be done, coding's only a tool. It's a tool that can solve certain problems. But a true engineer is not someone who is tied to tools. It's someone who is tied to finding out which tools are going to solve a problem. So you look at... When I say true engineer, I could just say anyone, right? You look at that's something you want to do, and you look at the problem and you say, we need to solve this problem. Here are all the things I could do to solve this problem. I can break it down to parts. These are the levers that I can pull that will make things happen. And these are the kinds of results we get from that. What tools do we have that we can apply to this situation? So sometimes it's going to be something like C, but sometimes it's going to be something completely different. Sometimes it's going to be, we're not going to write anything new for the program, but what we're going to do is make the inputs and outputs to the program shaped in such a way that humans can understand them. So we might go through and just change the order of the variables, and we might get a huge increase in how well a program works. So weird things like that, when I say change the order of the variables, I mean like change the order of the way they're presented to the user. So for example, if we did CS Paint, and we never used a new line on each row, so the output from CS Paint was just a single line of digits, I think that would seriously tank probably 40-50% of the class and your capability to actually complete the assignment. So if I made it so that it was just a little bit more difficult for you to read the output, or another possibility is if we hadn't given you the print canvas function. Is it called print canvas or display canvas? I haven't looked at the actual solution for a while. I've got like a copy of it that I wrote ages ago, but like it's not it doesn't have the same function names because I wrote a lot of them myself. But yeah, the function that prints out the canvas. If we gave you the assignment without that, then everyone's debugging would be a lot slower, because you'd be like, how do I know what my data is doing? Whereas we give you something where we say, okay, if you don't change this, we guarantee it's going to print out what's in your canvas. Then you can trust it, and then your testing gets easier. So lots of funny little things like that where design for how you're going to get around problems is nearly more important than solving the problem itself. It was display canvas. Thanks, Izzy. All right. I feel like I'm just filling time now, although, I don't know, some people might find this interesting. I think that we have, especially because that whole time where I was talking about just random stuff like that, we didn't get any questions that people needed answered or anything like that. So I think we may wrap it up here. I'll give everyone a couple of seconds to throw in a final question if you want to, because we still have time on the clock that we could use. So if anyone wants to look at anything, I'm happy to do that. Otherwise, I think we've seen a lot of interesting stuff today, because we delved a little deeper into several topics that we've covered in the course, and even looked at a pointer to a pointer, even though, hang on a second. Just gonna put that comment in there. Here be dragons. This is complicated stuff that people don't necessarily need to know about. Trent, Sony, Nintendo, or Microsoft? What day of the week is it, Trent? So, do I have friends over? Nintendo. Do I want... Okay, this is just very, very topical, because I've just been playing the Halo Master Chief Collection on Steam, and so like I have this fond memory of Microsoft and the glory days of the Xbox, which was the first Xbox about 20 years ago, I think, or even earlier than that. No, it was about 20 years ago. I think the first Xbox came out, and Halo hit, and it was just like, it was a revolution in cinematic first-person shooters, and I think that every first-person shooter after Halo borrowed a lot from that. So sometimes Microsoft, feeling nostalgic. Exclusive, amazing games that no one else has access to, Sony. So I still don't have PS4. I was like, which generation are we in? Because PS5's coming out soon. The fact that I don't have a PS4 means I'm missing the Spider-Man game, which I really wanted to play. At least Horizon Zero Dawn, which I wanted to play. A friend of mine worked on that. Came out on Steam, but I haven't gotten to it yet. So there's lots of little things like that. So, Sony, Nintendo, or Microsoft, I will jump between them. I think if it had to come down to it, Nintendo would win over the others because of consistency. Nintendo is one of the oldest gaming companies in the world, and it's one of the most consistently reliable gaming companies in the world. Like, if you see a game that has the word Mario or the word Zelda in it, you know that they didn't release it except if it was going to be one of the best games of the year that it was released in. So there's a level of trust that I think a lot of us have for Nintendo that no other computer games company has been able to replicate. This is funny because, like, as saying this, Anurag there is saying, what time are you going to be streaming on Thursday? And on Thursday is about computer games, which means that this conversation could happen on Thursday. If you're keen, you can come along. It's in the channel. It's also CC Soccer's running it via their Facebook channel. So if you sign up there, that's good for them because they want to know who's signing up for events and stuff like that. So Trent says, yeah, similar perspective. Yeah, I'm never really going to say one must win over the others. I would love it. What I would love is that every game that gets created for console also comes to PC. I would love it, and I don't mind if they come to PC late. That just happens. But I would love it if eventually we could play every console game on PC, because the PC's computing power develops more often. So PlayStation 4 is 6 years old now or something. Is it 6? Could be. Or 4 years old. Or, I don't know how old. But if we want to, not everyone can afford to do this, but you could update your PC every year And if you can update your PC every year, it's going to have significantly more computing power than the current console line, except at the point where they release. So if it's going to have more power, then it should be able to run everything. But it's only a matter of business and marketing, the reasons why we don't get them. Yeah. Hey Tom, we're just wrapping up. We're already shifted to talking about computer games and things. So I knew you were asking what time. Sorry, I call you Anu on instinct because I've got a friend who has the same name as you, Anurag, and we always call him Anu. So I apologize if I'm shortening your name and you don't usually do that. But the Thursday stream is 2 till 4 p.m. So the first hour of the stream is like a talk that I'm delivering. It's got slides and stuff like that. But it's going to be... I was going to say less formal than my lectures. My lecture's super not formal anyway. So it's going to be really similar to one of my lectures, but it's going to be me talking about computer games. I guess you might see me getting significantly more excited when I talk about computer games than when I talk about C. Like, I'm inspired to program a lot of the time, but computer games changed my life. So there's a difference there. There's a difference in seeing the glorious kind of art created by people around the world in the history of computer games, and that sometimes makes me a little bit more excited even than learning the tools to create computer games, which I find ironic because I've learned so many of the tools to create computer games and I love that, but there's still a part of me which is just a punter. There's a part of me that just wants to play them. I just want to let someone else make them and play them. So I will get excited about that kind of thing as well. Okay, I think we're going to wrap it up there because I think we are... Jamie's asked if I played Undertale. I have not played Undertale. I can't remember whether I own it. It's like, has anyone else got like what we call the pile of shame in your Steam library or something? Like Steam library is very PC based, but if you're playing games on PC, chances are you have Steam installed and then you have a library of, I don't know how many I've got, probably something like 500 games. And the actual completion rate of those is somewhere around like 20%. So, yeah, I may even own it, but I just haven't played it. So there's so many games and not enough time. And then while there's all these games, there's all this, like, I have to teach this course. I have to keep preparing content for these people and making new assignments and all this kind of stuff. What I need is for everyone to subscribe to my stream, and I'll flick it over to just me playing games. And then I can play Undertale on stream. And then if we can get the stream up to the point where you make me as much money as I make as a lecturer, then I'll quit my lecturing job and become a pro streamer. Because I've already got the funky microphone. The funky microphone for being a pro streamer. I always joke about that. Because I don't think... Yes, I know that there are streamers that make bajillions of dollars, but I just don't think that in general streaming is a very... Sorry, moving the camera around a lot is a very lucrative thing to do. And Trent's like, pile of shame. Yeah, you own 160 games, and there's like literally 69 games that you haven't played. Yeah, and I think that happens to all of us, because every time something goes on sale that we think we might want to play sometime in the future, we buy it. Even though we kind of know that that is not a good strategy, because games do not go up in value. Like, games always get cheaper. If you just leave them long enough, they get cheaper. So jumping on a sale and buying something that you're not going to play immediately is just falling for the marketing hype. Like, you haven't done anything for yourself there. Unless you really think that you want to support particular artists and particular game makers, you want to make sure that they get pushed. In that case, pre-order things and buy special editions to put more money into those people's pockets if you want to. And I think that involves really, really liking their stuff, and that's totally cool to do that. But yeah, buying stuff specifically on sale and things in Steam is a trap. It's always a trap. The cake is a lie. All right, I'm gonna wrap it up here because we're well off topic now, but I mean it's fun, and I think we've answered all the questions that were asked today. I hope. I think I went through all the chat. I hope, and I answered all the questions. So we're gonna wrap it up there. If anyone's interested in my talk on computer games, that is gonna happen on Thursday, and on Friday I'm gonna talk about. The title of the talk is Professionalism. And it is about professionalism, but it's not just about how to get a job. It's also about how to get a job that you want to keep, and how to survive working in an industry where there are a lot of people who are going to try to squeeze you dry and get everything they can out of you, and then just kind of throw you away when you're too tired to keep working. So we're going to talk about a lot of those things, and I think that's it's something that's really interesting because it's something that can't be assessed, because it's something you won't really know whether you've learnt from until you start working. But it's the kind of thing that a lot of people that I've spoken to find very, very important for computing graduates, but not just computing graduates. This is going to be people working in general, these kind of skills that are very important. You can tell I was talking for ages because the screensaver came on. Anyway, we'll wrap it up there. I will see some of you on Thursday, some of you on Friday. If not, I'll see most of you next Tuesday. Thank you for coming along, and I hope that a lot of these details that we went into here have helped open your eyes a little bit more about some of the deeper ramifications of doing things. Like we looked at 3D arrays and pointers to pointers and stuff, so there was a lot of extra stuff going on in here. So hopefully it's like, it's something interesting, because you can think about in the future when I understand more about about programming, I will be able to use these things. So these tools come into my toolbox and I'll be able to do more stuff. All right, thank you all. See you soon.